Good morning, everybody. So this is our second lesson on box plots. The first one was a little bit long because we were creating box plots. And it's not hard, but it takes time. In this case, our focus is going to be on reading and understanding box plots. Somebody else created them for us. That'd be nice. And we just have to pay attention to them. Okay. So this lesson honestly should be a little shorter. Okay. Now you have this in your notebook, I hope. It was provided to you. But let's take a look. General shapes of data. So in this one, the left whisker is longer than the right, and most of the data values are on the right. Okay. So we would say that because most of the stuff is on, okay, we're going to say that this is skewed. Okay. We're going to say that this is skewed left. That means that the left is less important. Okay. Now, I've heard it both ways, and that's why you heard me pause there. I've heard it skewed right means most of the stuff is on the right, but that is not what I'm reading. Okay. But what I want you to notice is that it's pushed over one way or the other. Okay. If it's centered, we would call that one symmetric. Okay. And then this one is skewed differently. Okay. Now, I might ask you to describe it, but I'm going to ask things like, where do you see most of the data? What does that tell you? So whether the exact terminology you use isn't somewhere we're going to lose our mind about in our class. Okay. So looking at this one, it's temperatures, great source of data. We want to look at what are the minimums, and I understand that in the video, it's going to be a little hard to see some of these. So I'm going to zoom in as much as I can, but I'll also say the numbers. So the minimum is this first dot. Okay, minimum is 78. Okay, your lower quartile is right here. Looks like 79. Median, 81. 84 is the upper quartile. And maximum is 90. Notice, I taught you to build them before I taught you to read them. That's on purpose because now when you go to look for those spots, you know exactly where to look. Okay. Now the range and the IQR. Okay. Range would be your maximum minus your minimum. So 90 minus 78. Okay. You have a range of 12. Okay. But your IQR is just 84 to 79. That range is only, oops, I'll do equal sign, 5. So your interquartile range is very small. Now, these are high temperatures. We don't know where and we don't know when. But look at this. 90 is extreme for them. They're almost always between 79 and 84. I'm pretty sure these are the temperatures of heaven because this is amazing. But you guys see where you can say, oh yeah, well, it's probably going to be 79 to 84. That's a normal range for them. That is why we use interquartile range. Okay? So let's look at 7. It's pretty centered. These are class sizes. I hope they're pretty centered. Your minimum, 21. Only 21 people in the class. Your maximum, 33. Okay, still smaller than our maximum. Your median, 28. Your lower quartile, 25. And your upper quartile, 30. Range again. And I'll just use R instead of IQR. You're looking at 33 minus 21. Okay, so you have a range of 12. Your IQR, you're looking at 30 minus 25. So your normal class sizes only vary by 5. Okay, so for me then to say, well, most of our class sizes are between 25 and 30 students would be very fair and accurate information. That's what these are useful for. Okay. Now, here's what I want you to do for try problems. I want you to take number 8 and number 9. For number 8, you're just going to need the data, the numbers. For number 9, okay, you're just looking for a true statement and be prepared to kind of say why it's true. And I'm going to collect the answers for these when I see you again. Like I said, much shorter lesson today, but incredibly useful on how do we use these pieces of information to make determinations. Can't wait to see you again.